So my first step is to change the inequality to an equation. And that becomes my equation. I'm going to graph it. I can use any method. I chose to go with the x-intercept and the y-intercept. Now let's find these 2 points. X equals 3. Where is x equals 3? 1, 2, 3. That's the x-intercept. The y-intercept is where? At 2. And now that takes me to step number 2. Normally we connect these 2 points, but before you connect them, take a look. Look where? See what you have. If you have greater than or equal to, less than or equal to, if you have these two, you're going to connect them with a solid line. If you have greater than or less than, no equal, you're going to connect them with the dotted line. What does that mean, solid line versus dotted line? Let me take you back quickly when you have a problem like this. X less than 4, how would you graph that? Open circle of 4 and to the left. Why open circle? What does the open circle means? Good, good. The 4 is not included, right? What happens if you have x is less than or equal to 4? Solid circle, good. What's a solid circle means? It's included. Well, that's the same thing. A solid line means the line is included in my solution. Just like having a closed circle, a solid circle. A dotted line means the line is not included. That's equivalent to an open circle. So here the line is not included. In the solution. This is the line itself is included in the solution. So the same as solid circle and open circle. When the line is solid, because it says greater than or equal to, that means that line has to be part of the solution. This one says the line cannot be part of the solution. There is no equal. We use the dotted line. Now let's take a peek at our inequality. Do we have an equal with it? So that line will be in this case what? Solid line. So step number 2 is done. Now here's the solution to yours. The solution to this problem is either going to be above this line or below this line. That's why we changed that to an equation, to find that line that's going to divide the solution area from the non-solution area. So your answer is either going to be above this line or below this line. Now, if you're a gambling kind of person, you can say, you know what, I'm going to gamble. I'm going to say above and see if it's correct, or below. But if you really want to get the right answer, we have step number 3. We take a test point. What's a test point? You can pick any point not on the line. Not on the line. So let's pick a point that's not on the line. Any point that you want to. I'm going to pick the 0, 0. No reason, because it makes the math easy. So let me try 0, 0. Now let's plug it into the inequality. Go back to this problem. Is 2 times 0 plus 3 times 0, is that greater than 6? No. No. So your answer is going to be yes or no. So what happens? If the answer is yes, what do? We shade the side where the test point is. If the answer is yes, we shade the side where the test point is. Now my test point here below the line, but my answer is not yes, my answer is no. So what happens then if the answer is no? we're going to shade one side. So, exactly. If the answer is no, then we shade the side opposite to the test point. Test point side. There we go. Let me take a peek here. Test point. Pick any point not on the line. I picked a point 0, 0. Plugged it in. It says, no, that's not bigger than 6. If my answer is yes, we shade the side where the test point is. If the answer is no, and that's what we have a no for an answer, we shade the side opposite to the test point side. This is where the test point side is. What is the side opposite to that then? Above that. Because the test point happens to be below the line, so you're going to shade the side opposite to that, so my solution will be this area. Any point in that area will fit that inequality. Any point. So on the test, they might ask you, where does your test land? In which quadrant? Remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this one is what? 4. So your answer in 1, 2, and 4. 1, 2, and 4. You have a piece in 1, you have a piece in 2, and you have a piece in 4. The only one doesn't have a solution is quadrant 3. But these are the 3 steps I'm going to use every single time. Change to an equation. See if it's solid or dotted line. Step number 3, take a test point. Let me try another one.
What if it's equal to?
What do you mean if it's equal to?
Like if you picked the point 1, 1. Like
It won't be equal. That's why you pick a point not on the line.
Oh, okay.
By picking a point not on the line, well, if you plug it here, if it's equal to, then that's true statement. That'll be true statement.
Okay.
But because you're picking a point not on the line, it's not going to be equal to. Okay. But if it did, that's fine. But you don't want to use a point on the line because it doesn't tell you anything. It's always going to be yes. Let me try another one. Y greater than or equal to x plus 1. What's the first step? Change to an equation. And that becomes what? Y equals x plus 1. And now you're going to plot that one. This, obviously, I can plot it probably by picking points or the slope intercept. You don't have to use the x and y intercept all the time. So this one, maybe I'll do a little table here. X versus y. When x is 0, what's the y value? 1, good. When x is 1, what's the y value? 2. When x is 2, what's the y? 3. So here we go. So 0, 1, that's this point. 1 and 2, that's this point. 2 and 3, that's this point. Step number 2, before you connect them again, take a look. What do we have? We have greater than or equal. Once you have equal sign, that means you're going to connect that with what?
Solid line.
Solid line. So these points will be connected with the solid line. Yep. Step number 3, pick any point for a test point that's not on the line. And I'm going to pick, I don't want to pick always 0, 0. Maybe I'll pick 2 and 10, which is right here. Let's pick that point. No reason why I chose that. Any point you want to. So I'm picking 2 and 10. And now let's plug it into the original problem. Y is 10, x is 2. Is 10 greater than or equal to 2 plus 1? Is that a yes or no?
Yes.
That's a yes. 10 is bigger than 3. So let me pull my sheet back. Let me look at this. If the answer is yes, you shade what? The side where the test point is. So since the answer is yes, shade the test point side. Now if you look at your test point happens to be above this line. So you're going to shade that side above this line. So my answer is going to be this. Which quadrant? 1, 2, and 3. Let me try another one. This time I'll make it y minus 2x is less than 4. I didn't put equal, less than. So change to an equation. Y minus 2x equals to what? 4. X and y on the same side. I'm going with my x-intercept and y-intercept. I could have moved the negative 2x to this side and becomes what? Y equals 2x plus 4. But I like this method. The x-intercept, you let y be 0. Y-intercept, let x be 0. When you let y be 0, what do we have? So negative 2x, right? Negative 2x equals 4. Good, because the y is gone. So what's x equal to? What is it? Negative 2. Very good. To get the y-intercept, we're going to let x be 0. So what do we have? Y equals what? 4. X is negative 2, that's right here. Y is 4, 1, 2, 3, 4, that's right here. Before I connect them, step number 2. Maybe I'll do this. Look. I'll make this like eyes looking at you. Stop and look. Staring at you, these eyes. What do we have? We have less than up there. See it? There is no equal. We have less than. So when you connect that, what kind of a line are we going to use? Dotted line, again, the dotted line means the points on the line are not part of the solution. So when you go to graph this on my math lab, there is one solid line and one dotted line. Make sure you pick the right one. Again, that means any point on this line will not be part of the solution. And my answer is going to be to the left of it or to the right or above it and below. It depends how you look at it. So it's either going to be on this side or on that side. And to decide which side, we take a test point. You pick a test point. Go ahead. What point you want to use? Any point not on the line.
1, 1.
1, 1. Good. 1, 1 is right here. So you want to use 1, 1. Nothing wrong with it. Let's test it. Is, in place of y, let's put the 1, minus 2 times, in place of x, put a 1. Is that less than 4? Is 1 minus 2 less than 4? Yes. Since my answer is yes, which side? Shade the test point side. And now where's the test point? The test point happens to be to the right of the line. So I'm going to shade that side. So where's my answer? In which quadrant?
1, 2, 3, and 4.
All 4. Yep. You got 1, that little piece, and 2. You see it? 3 and 4. All 4 of them.
Does that happen often?
Once in a while, yeah, sure. Let's try another one. The same 3 steps you're going to see me do every single problem. X minus 2y is greater than negative 6. Change to an equation. X minus 2y equals what? Negative 6. X intercept, y intercept. The x intercept, you let y be 0. The y intercept, you let x be 0. So this is x equals negative 6. This is negative 2y equals negative 6. Where is y equal to?
3.
Good. 3 plus 3. Because negative 6 over negative 2 is positive. The x-intercept is negative 6, that's right here. The y-intercept is 3, that's right here. Again, step number 2, take a peek, take a look. We have greater than on the top, which means the line I'm going to be using is dotted line. And again, my answer is going to be above that dotted line or below that dotted line. And that's where step number 3, the test point. Somebody pick a test point, any point not on the line.
2, 4.
2 and 4. See, 2 and 4 cutting it. I'm not sure if it's on the line or not. See that? So 2 and 4, I know I'm pushing it. But how about this one, 2 and 0? I mean 0, or is it 2 and 0? Yep. So I want to make sure I'm positive that point is not on the line. So 2 and 4, I'm saying, it could be, I know. So let me test the 2 and 0. I know that point definitely not on the line. Not on this red line. I don't care about the x and y axes. It can't be on that line. Now is 2 minus 2 times 0, is that bigger than negative 6?
Yes.
No. Yes.
2 is bigger than negative 6, yes. So shade what side? The test point side. The test point is on this side. Here's another example, all 4 quadrant, part of the solution. Let me put color twist in them. Two with the twist in them. This one. Notice it doesn't even have y in it. X is less than negative 3. Change to an equation. And that becomes what? X equals negative 3. And the question is, how would I graph that?
Negative 3 over 1.
Okay, negative 3 over 1. I'll put that. How is that going to help me? You think about the slope, I think. X equals negative 3. We have a suggestion, make it negative 3 over 1. I said, okay, let's make it negative 3 over 1. It doesn't really help me by making a fraction here. So what else can I do? How would I graph x equals negative 3? If you have x equals a number, the graph is always what? Want to take a guess? What's the graph looks like? Straight line. Up and down or left and right? Up and down. So x equals negative 3, that's this point. So it's going to be a line going up and down. The question again, is that line going to be a dotted line or a solid line? Before I decide on that, we take a look at it, look at the problem, and it has less than. Less than tells me that's a dotted line. So x equals negative 3, it's going to be, I'm going to connect it with the dotted line. If it was y equals a number, that would be left to right, horizontal. But x equals a number is always a vertical line. Now again, step number 3, we take a test point, any point not on the line. 1 and 1. 1 and 1 is right here. Let's try that point. Is 1 less than negative 3, because x is 1. Is 1 less than negative 3? No. Now, if the answer is yes, we shade the side where the test point is. Since the answer is no, we shade which side? Yep. Shade the side opposite. To the test point side. This where the test point side is on the right. The side opposite to that will be where? Which side?
Left of the dotted line.
Yep, the test point is on the right side. The side opposite to that side will be which one? Left side.
Quadrants 2 and 3.
Quadrants 2 and 3, correct. One more. Y is greater than or equal to 5. I did X before, now it's Y. Change to an equation. Y equals 5, and let's graph it. Now, since y equals a number, there's no x there, always equal to 5. That has to be a line that's horizontal. If it was x equal a number, it's a vertical line. Y equals a number, it's horizontal. That's y equals to 5, so it's somewhere in that direction. Again, is this going to be a solid line or a dotted line? We take a look and we have greater than or equal to, which means what? Solid line. So when I connect the points here, or draw the line, that's a solid line. And step number 3 is my test point. Maybe I'll pick 0, 0. Right here. I know that's below the line. Is 0 greater than or equal to 5?
No.
No. And if the answer is no, we should, yep, we should the side opposite, I keep writing that so you'll know it, to the test point side. So my test point side is below the line. That's where the point is, below the line. Opposite to that will be what? Above the line. Which quadrant? 1 and 2.